Welcome to Pavithra Laptop Care. So, this is part 3 of Type C. In today's topic, we can learn about types of connectors and PD, Power Delivery Protocol. The one is types of cable, second one is PD, what it is. So the main key word you have to note down is protocol. How it work and where it will work. So the types of power delivery: USB power delivery. So this also very small topic but really boring, but point has to be noted. Types of cables, PD, what is the protocol, USB power delivery, UFP already introduced, DFP. Okay, the word UFP and DFP, these two are very main things, please don't forget it. So depending on this, the power PD will delivered in type C circuits. So especially we are coming to the point of laptop motherboard type C section. So now onwards we can learn about laptop motherboard type C sections. So come guys, again we will come back to the boring section of PPT. See, in previous class I already explained about receptacle and cable plug. Receptacle is a PCB section, PCB part, and what are the pin it contains. So what data or what ground or what supply it contains, I already explained in part 1. So now it's very important to know about cables and its functions. See, there are 3 type of cables. So one is passive cable. Passive cables are required to carry the USB 2. See, before that, one thing I wanted to clear, this type C is not a special thing. It's a type USB 2, USB 3, USB 3.1. What it does, same function this also will do, the same thing only, but one major advantage is reversibly you can connect it. It's nothing but a USB. So please note down, it's nothing but a USB. USB 2, see, USB 2, USB 3, USB 3.1, all functions it has, but depends on functions, cable will differ. Now the passive cables are required to carry the USB 2 compliant signals. These are standards CC and VCON. I already explained you what is CC and VCON. Super speed and super speed plus protocols cannot be run on passive cables. So note down these protocols. What is that? Super speed and super speed plus won't carry. The normal type C cable won't carry these particular protocols. Passive cables do not work with the power delivery protocol. One more protocol is power delivery protocol, but can allow the downstream facing port to advertise and deliver additional power for the current mode. It can work as a PD, but it's not additional, it won't take much power, but it can advise to DFP and deliver additional power to the current mode, for the current mode. See, here is the simple example of passive cable. Now the second one is very important thing. So what are the laptop power adapter we are using? So in that we are using this particular cable. What is that? Electronically marked powered cable, EMCA. EMCA carry all type signals and are capable of running USB 3 speeds. Inside of these cables is an integrated circuit used to process the power delivery communication protocols. See, keep it in your mind. The PD power delivery is capable of depends on cables. Okay, not other things, not other circuits, because cable having that power capability. See, delivery communication protocols. It has a circuit inside the cable. It has a circuit to used to process the power delivery communication. The electronic marking allow for role switching, alternate mode selections, and enhanced power options. See, enhanced power options we are using in our laptops. Details of how these three items are implemented are provided on the power delivery protocol. The embedded electronics are powered by VCON. Type C requires both CC1 and CC2 to be capable of performing both the VCON and CC function. See, electronically marked cable, it has all signal communication lines. So internally it has a circuit. This is the cable. Inside the cable, active cable IC RA. I already explained in previous video. If you don't know about this, so please go and check the previous video. Otherwise you can't understand this. See, in this cable, VCON and CC both are there. This is the PCB section. Receptacle cable plug. Third one is also important, but we are not using in this particular section. So here we are using higher end functions. The managed active power cables. Managed active power cables have the same basic circuits as electronically marked cables, but have additional signal reconditioning capability. It has so many, compared to previous one, what I told, electronically marked powered cable, it has additional functions. So to do more functions. See, now we come to the USB power delivery. How power delivery functions will happen in the cable. Initially I told you should not forget about DFPs and UFPs. Those are very important. Now, USB has several methods of distributing power between hosts. Now we understood the cables, what kind of cables we have and what kind of the connectors we have. Now the power functions, how it functions. There are three type of power distributing in the circuits, type C circuits. One is default power, type C current mode, negotiated power using power delivery 2.0 protocol. See, these three kind of protocols, it's must. The type C current mode or what we are using, that we come to know one by one. Okay, the USB specification also provides for a battery charging specification to allow a USB host the ability to charge the battery of a device. See, now it started. One is default power, second one is type C current mode, third one is negotiated power using PD. Now, what is default power? That I already explained before, but once again I am going to explain. The USB specification calls 2.0 compliant host. It delivers 500 milliamps at 5 volts to an EMO-related device. USB 3 and 3.1 hosts offer 5 volts at 900 milliamps. This one is the first basic power delivery. Okay. Second one is type C current mode. Type C streams are capable of supplying more power than the default power of 2.0 and 3x systems. The amount of power delivery by type C systems can vary from system to system. Using the pull-up resistors, I already explained RP. Okay, using the pull-up resistor connected to the C1 and C2 signals type C, DFPs advertise to UFPs their ability to supply current in excess of the USB default power. See, here RP, it's a pull-up and here is the pull-down. It depends on the value of RP, the UFP will work. See, in this diagram, UFP type C cable, CC wire, for example, we will take it as a CC1 as connected to UFP side CC1. But here RP values advertise the currently delivery ability. So how much current it has delivered, this particular RP will decide. See here example 1.5 amps at 5 volts. If you are using this, RP value will be 22 kilo ohms, 5 volt signal. In case if you are taking it's a 2.3 signal, 3.3, then RP value will be 12K. Then current source will be 180 microamp. Here 3 amps at 5 volts. RP in case if you are using 5 volt signal, then 10K ohms. Then 3.3, it's a 4.7 kilo ohms. The current source will be 330 microamps. Power delivery protocol. See, everyone was waiting for this one only. I know this very much. So now here it's an introduction of PD. So what is that PD? Just you have a look at it. So USB power delivery 2.0 PD refers to the protocol used between a DFP, an electronically marked cable, and a UFP. See, the PD having a major role in between these three. What are those? It's a DFP, UFP and electronically marked cable. PD commands are transmitted through a cable's CC line. The PD commands, it's a protocol. The protocol commands are transmitted through a cable's CC line. Despite its name, PD is not limited to just power negotiations. Alternate mode and data role swapping of UFP and DFP roles are achieved through PD. Just here introduction, so in future you can learn more. But the thing is, you should not forget of DFP and UFP. See, here at startup, the DFP is a power provider. The DFP is a power provider. Once again I am repeating, DFP is the power provider and the UFP is the power consumer. USB is the power consumer. It's very important points, please note down. PD provides for the power provider here DFP to inform the power consumer, here it's a UFP, what current and voltage levels can be delivered. See, in laptop motherboards we require 20 volts, right? But in type C by default it will be 5 volts, right? The PD communicate between this DFP, UFP and cable, then it will decide what amount of current it's required. Okay, the power consumes will inform the power provider DFP of which profile it wants to use. Which profile in the sense, in the laptop you need it's a 20 volts, so 20 volts, and ampere rate also will be high, wants to use, and which voltage level is required. The power provider then sets the appropriate voltage level, which I told it's a 5 volts it required, 15 or 20. It depends on communication between DFP and UFP and the cable. There are 5 standards protocol profiles available for PD. For PD, what are the 5 protocols? One is 2 amps. In case of 5 volts, it's a 2 amps, 10 watt. Here 12 volts not available, 20 volts not available. Second one is 2 amps, 10 watt, 1.5 amps. Here if you want it's a 12 volts, then it's a 1.5 amps. Next, if you want 5 volts, it's a 2 amps, 10 watt. 3 amps 36 watt, 2 amps 10 watt, 3 amps 36 watt. Here 20 volts started. See, 20 volts adapter, 3 amps current it will carry. It means 60 watt. One more 2 amps. See, the 5 volts, if you want 5 volts max to max, it's a 10 watt only. If you want 12 volts, it's a maximum 60 watt. It may be more, but at present technology it has 60 watt. And if you want 20 volts, maximum 5 amps. It means it's 100 watt. Now it's more than that also is there. The PD allows the provider and the consumer roles to be switched at any time. The PD, see, provider and consumer, consumer roles to be switched at any time. It may change, it may switch between DFP and UFP. See, here it's just introduction. In future, using the diagram, you can learn more. Okay, now to be continued. Thank you very much.